Okay. Yes. Now it is fine.
Yes, sir.
Okay. So अब देखो, the topic was basically right exactly over here. और कौन सा टॉपिक था हमारा? रिफ्रैक्शन का टॉपिक था, और रिफ्रैक्शन के टॉपिक में आई टोल्ड यू अबाउट कि वंस द ऑब्जेक्ट, यानी वंस light is traveling from less denser medium to more denser medium, or more denser medium to less denser medium, then what will happen? It will change its speed, and due to change in the speed there will be a refraction in the light, and that refraction will be basically considered as uh, यानी that will result as bending. अब आप देखो, मैंने वहां पे आपके साथ एक चीज डिस्कस की थी इन द लास्ट डिस्कशन, दैट वाज दैट रिफ्रैक्टिव इंडेक्स इज इक्वल्स टू n, and it is equal to sin theta r divided by sin theta I. It was actually the ratio of sine of angle of refraction to the sine of angle of incidence according to this diagram. Is it? According to this diagram, this was sine of angle I, this was sine of angle R. अब देखो, light is bending, light has to move on this path. ये original path था, but now light is bending towards the normal. When the light is bending towards the normal, so angle theta R will become less than that of angle of incidence I. But actually, once we are taking the sine of that, the ratio will be given, ratio will be equal to a constant number, and that constant number was called refractive index. ठीक है बेटा जी? Is this clear till now? Okay.
Yes, sir.
Yes. So अब हम लोगों ने रिफ्रैक्टिव इंडेक्स का एक और कॉन्सेप्ट भी दिया था आपको. I was talking के bending का major reason was your speed of light. Is it? So once the speed is decreasing, तो इसका मतलब ये हुआ कि your speed can also be used to calculate the refractive index, and this refractive index is basically equal to uh, the speed of light in the medium to the speed of light in the sorry, speed of light in the air divided by speed of light in the medium. सही है? इसमें कोई कंफ्यूजन तो नहीं थी. अब हम लोगों के पास इसका फॉर्मूला बन गया था C by V. आज हम लोग डिस्कस करेंगे the specific effect, yani special case in which the light is traveling from more denser to less denser. Light is traveling from more denser to less denser, and it is actually having a specific condition. That condition will be met के आपके पास total internal reflection occur हो जाएगी. सही है? इससे आज हमारा टॉपिक स्टार्ट होगा कि व्हाट इज टोटल इंटरनल रिफ्लेक्शन, व्हाट आर कंडीशंस फॉर टोटल इंटरनल रिफ्लेक्शन, एंड हाउ डू वी कैलकुलेट टोटल इंटरनल रिफ्लेक्शन, एंड हाउ रिफ्रैक्टिव इंडेक्स इज रिलेटेड विद टोटल इंटरनल रिफ्लेक्शन. तो स्टार्टिंग विद दिस टोटल इंटरनल रिफ्लेक्शन की कंडीशन क्या है? कंडीशन इज के सबसे पहली बात आपने याद रखनी है कि लाइट मस्ट एंटर फ्रॉम लेस डेंस सॉरी मोर डेंसर टू less denser medium. Simple that once the light is entering from more denser to less denser, that time the light will be having, and it is possible that light will undergo the total internal reflection. Is this clear?
Yes, sir.
Second condition is the angle of incidence must be greater than critical angle. I will talk about critical angle in detail, but the situation is once the angle of incidence must be greater than critical angle, then light would undergo total internal reflection. अब आप देखो दो conditions हो गई. Condition number one, that light must travel from more denser to less denser. Is it? More denser to less denser. If it is not happening, total internal reflection will not take place. And second thing, angle of incidence must be greater than critical angle. Now, what is this critical angle? Critical angle is actually that angle of incidence in the denser medium for which your angle of refraction becomes 90 degree. You will be asked about this critical angle, state critical angle. Mostly 2 marks question आता है. ठीक है? ठीक है जी?
Yes, sir.
So the angle of incidence in the denser medium, angle of incidence in the denser medium for which the corresponding angle of refraction is 90 degree is called a critical angle. Is it clear to you?
Yes, sir.
अब देखो डायग्राम पे आते हैं. In this diagram, I have drawn uh, two, three different angles. All these angles are of different colors. For example, सबसे पहले the light incident uh, from more denser to less denser. देखो glass slab है and here you have air and light is entering from glass slab to air at different angle. So once I'm going to incident light from glass to air, first of all I have selected this ray number 1. This ray is incident at an angle theta 1 with normal. ये black वाला normal है. Okay, so this is normal. So light is incident at an angle theta I with या theta 1 कह सकती हो with the normal. And this light is refracted at an angle R1, angle of refraction 1 over here with the normal. अब आपने क्या किया? You have increased the angle of incidence of the light. So once you have increased the angle of incidence of the light, what impact is there on the refraction? अब आप देखो, the angle of refraction has been increased and now in a specific situation, the angle of refraction is now 90 degree, isn't it? Check this one out. This is your angle of refraction. So angle of refraction becomes 90 degree. So I can say that this is a time when the light ray becomes parallel to the boundary of the medium. This is boundary of the medium. So now what happened at this angle? At this angle, the light ray is incident at an angle greater than theta 1. So let me call it theta 2. This is theta 2. Theta 2 is greater than theta 1. Do you agree? नजर आ रहा है सामने कि theta 2 is greater than theta 1. So when theta 2 is greater than theta 1, we can simply say that at this specific angle, the light has refracted, or light is parallel to the, yani refracted ray is parallel to the surface. Now this angle is called critical angle. यानी देखो critical angle हम लोग इस angle को कहते हैं where you cannot decide whether the light will come back to the tensor medium or it will go out. So this angle theta 2 is equal to critical angle. Okay, so theta 2, hence theta 2 is equals to your critical angle. Why? Why is so? Now this is the explanation here for critical angle in this diagram. If you see, I have written that theta 2 is equals to critical angle. Why? Because theta r at this angle becomes 90 degree. And according to definition, that angle of incidence for which that angle of incidence for which the angle of refraction becomes 90 degree, that angle of incidence is called critical angle. Is this very clear to you?
Yes, sir.
Okay, so I'm just going to erase this all. So step by step, you will consider this situation. Now, check this one out. What do you think from this diagram? Only one ray, only one angle of incidence, only one angle of refraction. So this angle for which the light becomes parallel to the boundary, this blue uh, line here, this is actually your angle of refraction. It is 90 degree. So this angle of incidence is equals to your critical angle. So is this clear?
Yes, clear, sir.
Okay, good. So at this specific situation or at this specific stage, if I apply Snell's law, this is basically your Snell's law, and what is being told to you or what is being stated to you in Snell's law. Snell's law tells us about the refraction of two light rays, or a light ray when it enters from one medium to another. So n1 sine theta 1 equals to n2 sine theta 2, where n1 was the refractive index of that medium from which the light is uh, transmitted, or from which the light is basically propagating into the second medium. So here, this n1 is your initial, yani medium number one. You got my points? This is first medium. And what about this? N2. Sorry, I have to write it at the top. Yes. N1 is the refractive index of medium 1, yani denser medium. And what about N2? Is the refractive index of less denser medium. Is this clear?
Yes, sir.
तो मुझे ये बताइए कि what is that less denser medium? Isn't it your air?
Air.
And
Yes, sir.
isn't it your glass?
Glass.
So, if I say that the refractive index of glass is n generally, then sine theta I, because I told you here angle of incidence is your critical angle, and n2 is your 1, because that is air, and the angle formed in air is 90 degree. Is it? Angle formed in air is 90 degree. So that is why this theta 2 is sine theta 2. Sine theta 2 is theta 90 degree. So I just replace this value by 90 degree. So once I replaced it by 90 degree, I came to know that n sine c equals sine 90. So what's sine 90? Isn't it 1?
Yes, sir.
So sine 90 is your 1. So when sine 90 is 1, you can just replace it here. This at this step, that n sine c is equals to 1. So when this step is clear to you, n sine c equals to 1, then you will be very clear about critical angle. That is sine c is equals to 1 upon n. Okay, and from here n is equal to 1 upon sine c. So simply speaking, if I have the concept of if I want to find out the relation between critical angle and refractive index, I will simply uh, join these 2 points, yani these two equations, that critical angle equals to sine inverse 1 upon n, or n equals to 1 upon sine c. So whatever is convenient for you, or whatever is easy for you, you can write it. Is this clear to you?
Yes, sir.
Okay. So moving on to the next topic, that is total internal reflection. This was critical angle. So till this point, any confusion, anything you want to ask me?
No, sir. No questions. No confusion.
Oh, great. Now, after this, if you have increased the angle of incidence a little more beyond this critical angle, now check this one, theta 2, theta 3, the blue one. This theta is, and this angle is greater than theta 2. At this point, instead of becoming parallel to the boundary, the light has reflected back into the denser medium. This means that now the light is coming back to you. This is called your total internal reflection. So I defined it earlier that when the angle of incidence become greater than in the critical angle. Instead of refraction, the light reflects back into the denser medium. That is called your total internal reflection. So I'm just going to give you the definition here. So here is the space. So I can write total internal reflection. Sorry, this is taken off. Okay, so you can simply say that when the light becomes when angle of incidence becomes greater than critical angle, instead of refraction, light reflects back in the denser medium. Into denser medium. Okay, we call this as total internal reflection. Is this clear to you?
Yes, sir.
Okay.
Sir, 1 minute. Can I just write it?
Yes, yes. Why not?
Okay, sir, done.
Done.
Yes, sir.
Okay. So this is all about your total internal reflection. Do you have any question related to this?
No, sir, no questions.
Okay. Now, in the next discussion, we will be talking about reflection through prism. Although this is a specific situation or special situation in which the light entering on one side of a prism at a certain angle, not exactly 0 degree, but at a certain angle, is not moving straight or it is not traveling straight. Rather, it is deviated. Check this one out. So, this deviation of the light in the prism is due to refraction of the light or refraction. There are two reasons for this. I have to figure out the reasons here. One reason, that the light has different wavelengths. Okay, the light has different wavelengths, and the second thing, the prism has different refractive index. There are reasons for that, and the reasons are: reason number one, that the light has different wavelength lambda. And what about the next? The next is prism has different refractive index, yani n, at different portions. At different portions. Yani at the top, it has less, a smaller refractive index. At the bottom, refractive index is more. So this all is, you know, oh, sorry. Is it clear to you? Now is it visible?
Yes, sir.
Okay. So this is one of the reasons that why do we have the different pending structures or pending levels of light in a prism. So when light enters in a prism, it bends at different angles depending upon its wavelength. And I have given you a table in front of you and a sequence in front of you that first of all ROYGBIV. This is a complete sequence of all the light components in which red has the least bending. Then you have orange, then you have yellow, then you have green, then you have blue, then you have indigo, then you have violet. Okay, all these colors have different wavelengths. You know, what is the wavelength of red light, by the way? It is 400 nanometer. Sorry, 700 nanometer. Sorry, my bad. 700 nanometer. It is 650 nanometer. It is 600 nanometer. It is 550 nanometer. It is 500 nanometer. It is 450 nanometer. And this is of 400 nanometers. Right? These all wavelengths are included in your syllabus, and we have to know about all these wavelengths. So this slide is, although it is jumbled up a lot, but it has a lot of information. Is it clear to you?
Yes, sir. Clear.
Okay. So here n is smaller. Here n is more larger. That is why the refractive index varies with thickness. So that is why the light has different level of bendings. So when a combined light is incident over here, I mean composite light, that composite light is split it into all these seven colors. But if you incident individual light component like red, then you incident violet, then red will have least bending and violet will have the most bending. So there is, I think this much is enough for the refraction through prism. Any question?
No, sir.
Okay. Now this one for both. Yani, there are actually TIRPs. What does it mean by TIRPs? Total internal reflecting prisms. Total internal reflecting prisms. Okay. Total internal reflecting prisms are those prisms in which the light reflects back. For example, I have given you one example. There are so many and they have a lot of applications. Let's say this is a prism, and in that prism, we have the light incident from different sides. Let's say, yes, suppose the light is incident at this surface. Okay, now my question is, will this light bend? Will it deviate? Will it refract or not? What's your choice? What's your answer? Yes.
Yes, sir.
Will this light bend, smooth, straight, or what will happen to this light?
So will it go downwards?
Downwards. According to the rule, it is bending from sorry, it is entering from more denser to less denser. So according to rule, it this is the normal. This is the normal. Okay, I will draw normal here. I will draw normal. This is the normal. Okay, so this is normal to the surface, and the light enters parallel to the normal, isn't it? Yes, Fatima. Light normal पे incident हो रही है ना?
Yes,
It
sir.
is entering parallel to the normal, perpendicular to the surface, but parallel to the normal. So when it is entering parallel to the normal, what is the angle of incidence here? Shabash, come on, yaar. What's the angle of incidence?
Zero.
Zero. Very good. Why are you so scared of? Angle of incidence is zero. So when angle of incidence is zero, sure short, angle of refraction will also be equal to zero.
So,
That's it.
okay.
So according to this, n is equals to sine I upon sine r. So if you want to make this sine r as a subject, so sine r equals sine I divided by n, whatever n is, but sine I 0. So it will make everything 0, is it? So sine r will be also equal to 0. I mean, r equals to 0. That is why the lights will travel without bending. देखो, एंगल 0 होने का मतलब क्या है? The light will remain at the same path. It will not bend. It will not deviate. You got it?
Yes, sir.
So this is what, that if we have this all, then we can say that light is actually reaching to this point. Okay, here is another technical point. Here, what do you think? What will happen to the light here? Here, I will just split this diagram. देखो, आपके पास यहाँ पे फिर नॉर्मल बनेगा ना?
Mm,
And that normal is this. Mhm.
yes. Yes, sir.
Agreed? So
Yes.
when this is the normal, you can say that this normal is actually, yeah, at is 90 at 90 degree with the surface. So this is normal. सही है? Am I right?
Yes. Yes,
अब
sir.
बताइए, what is angle of incidence here? This is angle of incidence.
Yes.
So is this angle equal to 45 or not?
Yes, sir. 45.
This is 45. Sure short it is 45. So when it is 45, तो आपको सीधा सीधा देखना है कि when angle of incidence is 45, this angle is greater than this angle is greater than the critical angle. Is it?
Yes, sir.
That is 45, and 45 degree is greater than critical angle of the glass. And for this prism, let's discuss that critical angle for this is 42 degrees. 41.5 होता है. आप refractive index से calculations कर सकती हो, because here I did not put you in the table, but you can calculate here. For example, for the glass, refractive index is 1.5. So if you want to find critical angle, which formula will you use? Critical angle is sine inverse 1 upon n. कैलकुलेटर पढ़ा हुआ है?
Yes, sir.
करिए जरा. साइन इनवर्स 1 डिवाइडेड बाय 1.5 करो.
41.81.
Yes, 41.8, which is equals to 42 degrees. Is it?
Yes, sir.
So that's it. अब आप मुझे ये बताइए कि if angle of incidence is greater than 42 degree, then what will happen? will this light come back to the same medium, or it will move away from the medium, or it will refract? Shabash.
Sir, 48, 45. Total refract होगा, but internally.
Yes, total internal reflection is taking
Yes,
place.
sir.
सही है, ये बात क्लियर हो गई.
Yes, clear, sir.
The reason behind that is that angle of incidence is greater than critical angle, and once this angle of incidence is greater than critical angle, instead of getting refracted, the light is reflected back. And reflection का rule क्या है? The angle of incidence will be equal to same as that of angle of reflection. तो ये भी 45 डिग्री पे होगा. Now again there is a story. This story tells you that this is 90 degree to the surface, but it is basically parallel to the normal, isn't it?
Yes, sir.
यही normal है ना हमारा.
Yes.
So once it is parallel to the normal, can I say that angle of incidence is zero here? है ना?
Yes, 0.
Angle of incidence is zero at this point. That is why angle of refraction will be again zero. So
0.
light will not refract, it will move straight. Is this clear to you?
Yes, clear, sir.
Any confusion? Anything you want to
No,
ask me from this point?
no,
There
sir.
are so many applications. For example, this this mechanism is used in different ideas. Let me draw a diagram at the end of these notes for you. ये जो आपका TIRPs है ना, these TIRPs are used in different application areas. For example, binoculars, etc., etc. So let's say मैं आपको ये बता रहा हूँ कि once you are going to prepare a periscope. Do you know what a periscope is?
No,
पता है?
sir.
नहीं.
Yes.
A periscope is basically a sort of device which is used to see the objects from different position. For example, आपको मैं बताता हूँ कि this is a sort of structure like this. Like this. I will try my best to draw it. अब देखो, होता ये है कि the observer is here. ठीक है?
Yes.
And object is here. For example, there is an object, and that object is having एक बंदा है. ठीक है, ये देखो. ये आप इसको देखना चाहते हो पेरिस्कोप से. ठीक है, आप एक्चुअली यू आर बिलो द सरफेस. सही.
Yes, sir.
Then this is a sort of a this is a sort of submarine, or you are below the trench, or you are under surface. अब आप देखो, अगर आप इस बंदे को देखना चाहते हो तो what will you do? ये बंदा यहाँ पे आ रहा है. I will just draw 2 points, 2 rays. देखो, one ray which is coming from its head, it will reach to this point, it will reach to this point, it will reach to your eyes. That's it. सही है?
Yes, sir.
Simple. Then the other ray which is coming from its tail area, वो यहाँ पे आएगी, यहाँ पे आएगी, यहाँ पे आएगी. सही है?
Yes.
Now what did you observe? आपको बंदा कैसे दिखेगा? The black is at the tail and red is at the head. So you will see that, oh yes, the person is here. This is the guy. आप यहाँ नीचे इसको देख सकते हो. Do you see that?
Yes, sir.
ये सीन होता है पेरिस्कोप का. ठीक है? And you are using TIAS. सही है?
Yes, okay.
So we will be just winding up right now. Polarization का टॉपिक है. Inshallah, I will be back on that topic. Polarization का टॉपिक करके I will give you some sort of worksheet at this weekend. कल हमारी क्लास है ना?
जी सर है.
और कितने बजे? At same time. I think so.
Yes, sir.
Yes.
Almost.
ठीक है? कल मिलते हैं
Yes, sir.
इंशाल्लाह.
Okay, sir.
See you.
Allah Hafiz.
Hafiz. Hafiz.